When you're doing any data manipulation work, either in terms of the database or either in terms of the operating system, or whenever you're given any task to the CPU actually. So what happens is, in these kind of a critical operations, you have to must apply the lock on top of that, the mutex what we call it as. So if you don't apply the lock, what happens is, when T1 is running, suppose task 1 is running, and when it enters into the critical regions, so the critical regions is nothing but where all your data manipulation is happening, which is very important in terms of the operating systems. Okay, so if that is corrupted, the whole, you can see inconsistent data and corrupt data actually. You have to be very careful in that one. So when task 1 enters into the critical regions, it should complete the task and then only come out. Okay, so if it comes out middle, when it comes out of the middle, when you don't apply the lock on top of that, if you don't apply the lock, CPU what it does is, it only, if another task comes with a high priority, it will remove the ongoing thing, ongoing task which is already doing the work. It don't care about already something is going on, it only care about the high priority. If T1 is doing 100 records insertion, and within 50 records only it removed from the CPU, so definitely there will be a data inconsistency will be there. With the mutex, what you are telling to the CPU that, okay, until this task completes, don't remove it from the CPU. Okay, so let other task wait until this completes. So CPU does like that only when mutex comes. So when task comes, it do the work. Once it done the work, it come out and leave that lock. You have to leave that lock, otherwise what happens if you don't leave that lock is like, other task don't get that lock. So then they never gonna get the CPU in order to work with, and their entire life they will wait only and never run into the CPU. So that's why it is very important when you are doing the critical operations with the data.